In late 2025, open benchmark leaderboards showed a mathematically improbable shift. Offshore AI labs were suddenly matching the most advanced Western systems. This estimated cost breakdown is striking. Western labs spend up to €1 billion to ship a frontier system. These offshore labs hit the same benchmarks for 20 million, spending exactly €0 on PhD research staff. These results were achieved without the physical H100 and A100 semiconductor clusters required for traditional frontier training, hardware that is currently blocked by Western embargoes. These labs demonstrated that the AI supply chain can be virtualized. By decoupling training from hardware ownership, they moved the entire process outside the reach of physical export checkpoints. The labs bypassed embargoes using two distinct mechanisms: an unauthorized data extraction system called Pipeline 1, and an offshore rental structure known as Pipeline 2. Until January 2026, every step of this resource acquisition was legal under existing international trade frameworks. This suggests that a moat built on hardware ownership can be circumvented by a combination of unauthorized data extraction and rented compute. This table outlines three prerequisites for a frontier model: base weights, reasoning data, and compute. The foundation is base weights. Proprietary pre-training requires hundreds of millions of dollars. The offshore cohort bypassed this by downloading open weight models for free. While these open weights provide a structural grasp of language, they lack the complex reasoning capabilities found in proprietary models like Anthropic's Claude. To bridge that gap, the labs still needed two expensive assets: high-quality reasoning data and the H100 clusters required to process the training. The solution to the data problem was an operation that allowed them to acquire what would normally be $100 million of research using nothing but an API credit card. Pipeline 1, known as the siphon, utilizes model distillation. This is a process where a highly capable teacher model is used to train a less capable student model. Anthropic flagged 24,000 fake accounts probing the Claude API. They targeted it with engineered prompts, demanding complete chain-of-thought traces. By executing this at scale, they extracted millions of prompt and trace pairs into a massive fine-tuning dataset. This allows the student model to memorize Claude's precise reasoning patterns, rather than attempting to learn those logic skills independently. To evade rate limits, operators utilized residential proxy networks, routing API calls through the Wi-Fi routers of ordinary households to mask the coordinated traffic. Every inference endpoint that shows its work is effectively a training dataset in transit. The more a model explains its logic, the more extractable it becomes. Pipeline 1 solved the labor problem by siphoning the intelligence Western researchers had already produced. With the dataset built, the labs faced their final hurdle. They needed thousands of restricted H100 GPUs to run the actual training. The workaround relied on registering cloud computing accounts under holding companies in intermediary jurisdictions like Singapore or the UAE. Using shell companies, they rented up to 8,000 H100s from Western hyperscalers. The physical servers remained inside US data centers. Operators uploaded their distilled reasoning data and open base weights. The fine-tuning job ran entirely on US soil. Once the training run was complete, the resulting frontier model was compressed into a single file and downloaded back to headquarters in Shenzhen. This was legal because export jurisdiction applied to the physical shipment of hardware, not the remote digital access to it. Because the chips never left the country and the digital weights were not classified as commodities, the training run occurred entirely outside existing export controls. Pipeline 2 allowed foreign labs to rent the exact computing power they were forbidden from buying. In January 2026, the U.S. House of Representatives passed a legislative fix called the Remote Access Security Act, or RASA. RASA extends export framework authority from physical chips to the digital cloud access used to reach those chips. The act imposes know your customer rules on providers to verify the beneficial owner of high compute accounts. Additionally, training workloads exceeding 10 to the 25 flops must be logged with customer identities. Finally, it closes intermediary loopholes by explicitly blocking Singapore and UAE pass-through companies. RASA effectively patches the compute loophole for domestic data centers, but its legal jurisdiction is limited. Pipeline 1 remains a persistent threat. Distilling data from an API is a civil terms of service violation, not a criminal act. While labs like Anthropic can ban accounts, state actors can automate the creation of new residential proxy identities faster than detection can scale. Furthermore, Frankenstein models trained before RASA are already published on public repositories and cannot be retracted. The compute rental market is also likely to reroute to non-US hyperscalers in Europe and Asia within the next 12 months. Hardware ownership no longer functions as a permanent moat in a virtualized supply chain. Physical embargoes provide friction, but they are no longer an absolute barrier. This forces a shift in defensive posture, where every long reasoning case must be treated as an export-controlled artifact. A model that reasons well in public teaches well in private. A sustainable competitive moat depends on the reasoning patterns a lab chooses to withhold.